All right. Still got my cold. Might cough during this. I know my wife, she's watched a video like this where the instructor was coughing and she said it was really annoying, so I'll try to avoid that. So, three examples, hopefully quick, of exponential and logarithmic equations. Actually, probably four examples, don't think of it. But here's the first one. Here's an equation that looks kind of daunting. It's got e's and it's got x squared, x polynomials and stuff in it. And this is the kind of equation that often occurs in calculus, mixing e's and x's, and it looks really weird. And there's reasons to be dubious about such a thing, and I'll show you a quick example of where to be dubious about it. But this is not one of the cases that it's going to be actually too bad. The key here is to factor out all the e stuff. And sometimes that's not possible, but here it is, because the e to the x times e to the x, that's an e to the 2x. That's exactly the same as this, and so the e to the 2x factors out. Whoops. And we get an equation that's really very nice. Remember when I have the product of two things equaling 0, and it's absolutely crucial this is 0 on this side. When I get the product of two things equaling 0, either the first factor is 0 or the second factor is 0. And the great thing about e is it can never be 0, ever. And so that's just impossible. It's as if that were just a non-zero constant, and that's not a possibility, and so it just reduces to this being 0, polynomial, and that further factors, because I made it simple, and so that's going to be x equals 0 or 3. Boom. Now, a variation on that, let's call it 1 prime. Yeah, the prime doesn't work very well in text mode. Oh well, 1 prime. Let's suppose it was this whole thing, and it was not equal to 0. It was equal to 1. Well, then you could still factor it. Oops, didn't want to cut, I wanted to copy. There we go. But then now this is equal to 1. And remember, if this is not a 0, you can't use the zero product property. That's why it's called the zero product property. It's crucial that the product be 0. If the product of this e and this polynomial is equal to 1, this is not an equation that it is possible to solve in algebra. It is absolutely, provably impossible to solve this kind of equation. So unfortunately, very often when you mix e's and non-e's, an x inside the exponential of anything, it's not really e's fault, it's an exponential expression that's to blame. And if you mix it with the x inside and outside, unless it's of a rather special type like this, you're not going to be able to solve. Luckily, this kind of type shows up a lot, but this kind of type would require a calculator and an approximate solution. Now, what about this guy? Here, the x's are all in the exponent position, so there's some hope for it, but it could be problematic. But the 6x and the 3x being related, that's a crucial thing. Once again, laws of exponents, properties of exponents come in handy here. That first thing is e to the 3x, quantity squared. And so we've got something that only mentions x in the guise of e to the 3x. You don't have to do it this way, but a nice way to explain what's going on is to do a little temporary substitution and say, just use our power to name things here to say u equals 3x. Therefore, our equation that we're trying to solve is just u squared minus 5u minus 6 equals 0. And, oh, you know what? I was going to change this in the middle. You know, I'm going to use my instructor's prerogative to change this in the middle. Let's say minus 1. I forgot to change. I changed my mind of what example I was going to do. I want to make a further point here. So u squared minus u minus 6 equals 0. That factors into u minus 3 and u plus 2 equals 0. And so we think our solutions are u equals 3 and minus 2. And now we substitute back. That's just a shorthand for e to the 3x. Okay. So let's see what happens. If e to the 3x equals 3, then 3x is ln 3. Remember, that's crucial. If you got x in the exponent there, you're going to use a log at some point, unless it's a very special case. The kind of cases we started out with, but are no longer limiting ourselves to. And there's our solution, 1/3 of ln 3. But what about the other solution? What about the other situation? E to the x equals minus 2. Aha, that's impossible. E to the 3x is never going to be negative if x is a real number. And so, even though it was an equation of quadratic type, when we figured out this u equals u equals e to the 3x substitution, it only had one solution. Pardon my being tongue-tied. It's probably because I'm kind of cold. That's my excuse today. Now here's one with logs. How do we solve these guys? Well, we're expecting exponentials to come in at some point, but we also absolutely crucially need to use properties of logarithms. Remember, the biggest, most important thing we can do in algebra, if we can do it, is to get fewer x's in our expression. Fewer x's in our expression, or to get them closer together would be the first thing. And the way we can do that is to combine this into one logarithm. It also has the advantage of, hey, logs are complicated things. Why do two of them when you can do one of them? And the sum of two logs is the product, is the log of the product. Okay. Now we've got this 6 minus x expression. Who cares what it is right now? It's something inside a log. And log of something equals 3. That's something we can convert into something that doesn't mention the log and strips that layer off. That means that x times 6 minus x is equal to 2 to the 3. That's the fundamental connection between logarithms and exponents. And that's equal to 8. 8. Okay. And so we get minus x squared plus 6x. And let's see if I mess this one up as well as the last one. I think this is good. Let's just change signs here. X squared minus 6x plus 8 equals 0. And that factors into x minus 2, x minus 4 equals 0. So x equals 2 or 4. Now, check it. These might well not work. This one I wasn't trying to make that point, so I made them both work. If you plug in x equals 2, log 2 of 2 is 1, log 2 of 4 is 2, and you get 3. With 4, excuse me, the roles are reversed. Log 2 of 4 is 2, log 2 of 2 is 1, and they add up to 3. And so they both work. But you really should check, because there are definitely cases where there's going to be stuff that's subtle, but they might not both work.